magnetism. So first of all, this will be a basic introductory class. So magnetism हम लोग बात करेंगे. अच्छा, ये चैप्टर थोड़ा सा relatively different है. इसमें हैंड रूल्स लगते हैं, तो इसमें थोड़ा सा ऑनलाइन में कंफर्ट जोन होता नहीं है. बट मैं इसकी कैमरा खोल के कभी डबल रिकॉर्डिंग भी आपको सेंड करूंगा, तो उससे हम लोग हैंड रूल्स को कवर करेंगे. सो लेट्स स्टार्ट विद दिस टॉपिक. First of all, the very first point that you need to understand, every magnet has two poles. Every magnet has two poles. Namely, definitely the names are north and south both. So suppose this is the bar magnet. So at this end you have the north pole, and suppose the other side is south pole. So every magnet has two poles, and whenever you place two magnets together, like you are placing them together, यहाँ पे आपने एक और magnet, you are placing another magnet here. So if the magnets are facing their like poles, so definitely what is going to happen, suppose this is the first magnet, this is the second magnet. So they both will apply repulsive forces on each other. So force on first magnet will be to the left, and force on second magnet will be to the right. So like poles repels, and if they are facing by unlike poles, suppose these are unlike poles, yani ke if the magnet is placed like this, south pole is here, suppose north pole is here, and this is the south pole, and from here north pole is facing, right? So what is going to happen? These are unlike poles, so definitely they will attract each other. The force on first magnet to the right, and force on second magnet is to the left. So unlike poles attract each other. This is a basic property of any magnet, that the like poles are going to attract each other and unlike poles are going to repel each other. So this is a basic property of any particular magnet. Property इसलिए कह रहा हूँ क्योंकि they are naturally found, magnet आपके naturally found होते हैं, उनमें ये property होती है that they are going to repel their unlike poles. तो हम यहाँ पे लिख देंगे कि unlike poles attract each other. Now, what type of force is this? This is called magnetic force of repulsion. Between the like poles, I can say that F1 and F2 are non-contact. Non-contact matlab the magnets are not in physical contact. Non-contact force called repulsive magnetic force. Repulsive magnetic force. And definitely in this case F1 and F2 are also non-contact force है, मतलब the magnets are not touching each other physically, but still they are capable of applying force on one another. So this is non-contact force, and non-contact force called attractive magnetic force. So this is what we call attractive magnetic force. So magnets apply forces on each other, which is magnetic force of attraction maybe, or sometimes it is magnetic force of repulsion. So magnets do apply forces on each other. Acha, apart from that, magnets also apply forces on magnetic materials. And remember one thing, if we talk about the magnetism, the materials can be classified as either they are classified as magnetic materials, or they are classified as non-magnetic materials. Non-magnetic. So there are two types of materials in the world, which some are magnetic in nature and some are non-magnetic in nature. So magnetic materials are mostly metals. Most of the time they are metals, but all metals are not magnetic in nature. And non-magnetic materials are, non-metals are definitely always non-magnetic. And some metals are magnetic. Some metals. All non-metals are non-magnetic, but some metals are magnetic. Some metals, only some metals are magnetic. Some metals are magnetic in nature. Not all the metals are magnetic in nature, but few metals are magnetic in nature. Some metals are non-magnetic in nature as well. Some metals are non-magnetic in nature. Acha ji, what is magnetic? Magnetic metals are attracted towards magnet. Attracted towards magnet. Do not, and non-magnetic do not attract towards magnet. आज बिल्कुल इंट्रोडक्टरी क्लास है इसकी, तो उसमें आज मैं बहुत छोटी छोटी बातें करूंगा आपसे. Do not attract towards magnet, but definitely basics are very important. तो ये बेसिक चीजें आपको पता होनी चाहिए. Do not attract towards magnet. So non-magnetic materials do not attract towards magnet and magnetic materials attract towards magnet. अच्छा, अब कौन से फेमस मैग्नेटिक मटेरियल्स हैं हमारे पास? तो इन आर सिलेबस आयरन इज वेरी फेमस मैग्नेटिक मटेरियल. In our syllabus, steel is also a very famous magnetic material. But apart from that, we have many other magnetic materials like nickel, cobalt. But these are not famous with the syllabus. हमारे syllabus में these are too important. These two are very important. And they are pronounced throughout the syllabus. They are very important. And there are many non-metals. देखें, अब ये मैं ये अगर लिखूं ग्लास जो है वो नॉन मैग्नेटिक है तो सबको पता होता है. इफ आई राइट वुड में लिखूं तो सबको पता होता है, बिकॉज प्लास्टिक अगर मैं लिखूं तो सबको पता होता है कि इट इज नॉन मैग्नेटिक इन नेचर. बट all non-metals are magnetic in nature, but few metals such as silver is non-magnetic in nature. Gold is also non-magnetic in nature. Brass is also non-magnetic in nature. Aluminium is that material जिससे वो soft drink के cans prepare होते हैं. So aluminium is also non-magnetic in nature. So there are some magnetic materials in the world. There are some non-magnetic materials in the world. So non-metals are always non-magnetic in nature, but some metals have magnetic characteristics and some metals have non-magnetic characteristics. जी, कॉपर भी आपका इधर ही आएगा. वरीशा, बिल्कुल कॉपर भी आपका नॉन मैग्नेटिक वाली साइड पे आएगा. So these are magnetic and these are non-magnetic. अच्छा, अब होता क्या है, अब थोड़ा सा समझिएगा इसको. Suppose I have this iron bar. I have with me the iron bar. This is the iron rod. There is an iron rod, right? And I place a magnet here. and this is North Pole, and this is South Pole. What is going to happen? This is called permanent magnet. Now, first time I'm using such term, permanent magnet. Permanent magnet का मतलब ये है that it is not going to have its magnetism because of any other source. ये permanent magnet है. But whenever you bring permanent magnet close to any magnetic material, what is going to happen कि यहाँ पे इस पे एक pole आ जाएगा, that is north pole, और यहाँ पे इस पे एक south pole आ जाएगा. And these two poles are called induced poles. These are called induced poles. Now, why they are called induced poles? Because they are temporary. They will disappear. As you remove the permanent magnet from the picture, they will disappear. And this iron is somehow called temporary magnet. This iron bar is now considered as temporary or induced magnet. Induced magnet. Now, definitely, this permanent magnet which I have placed near the iron bar, near the iron rod, is going to attract this iron bar, and this iron rod is going to stick to it, and it will also behave as a temporary magnet. यानी इस पे भी poles create हो जाएंगे. But once you remove the permanent magnet, if you remove the permanent magnet, the poles will disappear suddenly. As you remove the permanent magnet, poles will disappear suddenly, and this rod is now said to be demagnetized. Demagnetized again. Demagnetized again. Demagnetized हो गई है ये rod आपके पास, because you have removed the permanent magnet from the picture. There is no permanent magnet in the picture right now. So this rod is said to be a demagnetized one. And this rod is said to be a magnetized one. Magnetized rod A, and this is demagnetized rod. But what is good about iron? Iron is going to acquire the magnetism so quickly. It will become a temporary or induced magnet in the surrounding of any permanent magnet very quickly become magnetized, and then when you remove the magnet from the picture, from the scenario, तो ये demagnetize भी फौरन हो जाता है. तो हम ये क्या कह सकते हैं कि iron is a soft magnetic material. Iron is a soft magnetic material. Now, why I am calling it soft magnetic material? Iron is a soft magnetic material. Soft doesn't mean its texture is soft. इसका ये मतलब नहीं है कि इसका कोई texture soft होता है. But soft magnetic material का मतलब ये होता है कि easily magnetized and easily demagnetized. Easily magnetized and easily demagnetized. ठीक है. अच्छा, now suppose I have this iron bar, sorry, my permanent magnet with me, and I bring a steel rod near to it. This is a steel. Now, if you bring the steel rod close to the permanent magnet, this will also acquire some temporary poles, and it will be attracted by the permanent magnet easily. This will be attached to it like this. But when you remove the permanent magnet from the picture, the poles on the steel bar are not ready to remove, are not removing instantly. Steel bar, steel rod does not demagnetize डज नॉट डीमैग्नेटाइज वेरी इजीली, मतलब ये फौरन से डीमैग्नेटाइज नहीं हो रही, it is not becoming demagnetized very easily, but it takes some time more, but it takes more time than iron, but it takes more time compared to iron, more time compared to iron. अच्छा, ऐसा नहीं है कि मैग्नेटाइज नहीं, डीमैग्नेटाइज नहीं होगी, हो जाएगी आफ्टर फ्यू सेकंड्स, हो जाएगी, ये तो इंस्टेंट हो गया ना, इंस्टेंटली डीमैग्नेटाइज, इंस्टेंटली डीमैग्नेटाइज. तो स्टील बार इज ऑल्सो गोइंग टू डीमैग्नेटाइज, बट इट विल टेक स्लाइटली मोर टाइम, मतलब इसमें 2-3-4 सेकंड लगेंगे मे बी हमारे पास, और ये डीमैग्नेटाइज हो जाएगी. तो देन स्टील इज कॉल्ड हार्ड मैग्नेटिक मटेरियल. स्टील इज हार्ड मैग्नेटिक मटेरियल. It becomes, अच्छा, why it is called hard magnetic material? Steel is hard magnetic material because because it is not easy or quick. It is not easy or quick. It is not easy or quick to magnetize. It is not easy and quick to magnetize and demagnetize steel. तो इसको मैग्नेटाइज और डीमैग्नेटाइज करना दोनों थोड़ा सा मुश्किल काम है. ये मुश्किल काम का मतलब इट टेक्स लॉन्गर टू बिकम मैग्नेटाइज एंड डीमैग्नेटाइज. बेटा यहाँ तक अगर कोई, इफ यू हैव एनी क्वेरी, एनी क्वेश्चन, तो प्लीज आस्क. एहसन, अमान, अमीना, बिलाल, हिबा, कोनैन, वरीशा, जुनैर, कोई सवाल है यहाँ तक तो पूछें, इफ देयर इज एनी क्वेश्चन. जी बेटा, आई थिंक नो क्वेश्चन फ्रॉम एनी स्टूडेंट. सही है, यहाँ तक बिल्कुल क्लियर है. जी बेटा कोनैन, क्लियर है बात. चलें जी, बेस्ट हो गई बात ये. अच्छा, हमने सिर्फ इंट्रोडक्शन देखा है इसका कि भाई मैग्नेट्स होते हैं, देयर आर टू पोल्स इन द मैग्नेट, like poles repel, unlike poles attract. Then it comes to the material. There are two sort of materials, like magnetic in nature, and some materials are non-magnetic in nature. And magnetic materials are also further classified. Magnetic materials और दो classes में classify हो सकते हैं as a soft. Some are soft magnetic material and some are hard magnetic material. But हमारे syllabus में soft में example आती है iron and hard में example आ जाती है steel. स्टील इज अ गुड एग्जाम्पल ऑफ हार्ड मैग्नेटिक मटेरियल. तो इन फ्यूचर हम इलेक्ट्रोमैग्नेट्स और परमानेंट टेम्परेरी मैग्नेट्स बनाएंगे तो उसमें आयरन यूज करेंगे, एंड इफ विल बिल्ड अ परमानेंट मैग्नेट तो हम उसमें स्टील को यूज करेंगे आगे जाके कोर्स में. ओके, सो इट वाज क्लियर. और अकॉर्डिंग टू दैट मैंने यहाँ पे इंड्यूस मैग्नेट्स या इंड्यूस पोल्स का भी कॉन्सेप्ट दे दिया आपको. अच्छा, नाउ द नेक्स्ट थिंग इज मैग्नेटिक फील्ड्स. नेक्स्ट थिंग इज मैग्नेटिक फील्ड्स. मैग्नेटिक फील्ड. तो अच्छा, अब देखें होता क्या है कि एवरी मैग्नेट every magnet has a space in its surrounding, where if we place any magnet or magnetic material, any magnet or magnetic material, so it will experience repulsion or attraction. अच्छा, अब देखें, if you have a bar magnet, if you have a certain bar magnet, let's suppose this is the bar magnet, so it's not like it will attract the magnetic material from any distance. It's not like it is going to attract the iron nail from any distance. No, it won't attract the iron nail from any distance. ऐसा नहीं है कि ये कहीं से भी कितनी भी दूर से iron nail को attract कर लेगा. It's not possible for the magnet to attract the iron nail from a very huge distance. Even if you place the iron nail a very long distance away from the bar magnet has no influence on that particular iron nail, because every magnet, according to its capacity, has some aura, has some imaginative region in its surrounding. Every magnet has some imaginative region in its surrounding, and that imaginative region or space is basically termed as magnetic field. So if the magnet is strong enough, if the magnet is big, so it will have a greater magnetic field, greater area in its magnetic field. And if the magnet is small, it will have a lesser region or space in its magnetic field. तो अब जैसे ये है, इसका ये रीजन है, इसकी सराउंडिंग में ना इमेजिनरी रीजन है, इसकी सराउंडिंग में, जिसमें ये किसी भी मैग्नेटिक मटेरियल पे कोई फोर्स अप्लाई कर सकता है. But it won't apply the force on any magnet, any magnet or magnetic material if it is beyond its magnetic field. तो अब इसकी भी सराउंडिंग में एक इमेजिनरी रीजन ऐसे फॉर्म हो रहा होता है. मैं इसको ऐसे शो करने की कोशिश कर रहा हूँ, ठीक है. अच्छा, इफ यू प्लेस एनीथिंग आउटसाइड दिस बाउंड्री, आयरन नेल, स्टील नेल और वट एवर अ मैग्नेट, तो मैग्नेट इसको अट्रैक्ट नहीं करेगा, कुछ भी नहीं हो सकता इसमें. अच्छा, इफ यू प्लेस हेयर iron nail inside its field, तो definitely it will attract कर लेगा इसको ये, ठीक है. तो iron nail if placed inside the magnetic field, inside the region, it will be attracted, otherwise it won't be attracted. तो अब हम करते क्या है, ये जो magnetic field होती है, इसको शो करने के लिए, इसकी strength को शो करने के लिए, we will make some lines which are called magnetic field lines. तो मैग्नेटिक फील्ड लाइंस आपकी नॉर्थ से स्टार्ट होती हैं और साउथ पे आके ऐसे टर्मिनेट हो जाती हैं, लाइक दिस. मैग्नेटिक फील्ड लाइंस आप बनाते हैं. अच्छा, ये इमेजिनरी जो लाइंस मैं यहाँ पे बना रहा हूँ ना, ये लाइंस आपकी कहलाती हैं मैग्नेटिक फील्ड लाइंस. These are called magnetic field lines. These are crab shape, इस तरह से बनती हैं ये कुछ. तो ये मैग्नेटिक फील्ड इन द सराउंडिंग ऑफ बार मैग्नेट है. तो हम ये कह सकते हैं कि इट इज द मैग्नेटिक फील्ड पैटर्न in the surrounding of any bar magnet. It is magnetic field pattern in the surrounding of bar magnet. In the surrounding of bar magnet. Acha, if you closely monitor, so magnetic field lines are running from north to south. So magnetic field lines are having the direction from north to south. Magnetic field is represented. Magnetic field is represented by making lines from north to south called magnetic field lines. Called magnetic field lines. अच्छा, आपको क्या लग रहा है ये मैग्नेटिक फील्ड लाइंस कहाँ पे ज्यादा डेंस है? मतलब किस जगह पे मैग्नेटिक फील्ड लाइंस ज्यादा जम्बल्ड अप है, ज्यादा क्राउडेड है? At which area in the bar magnet we have the more magnetic field lines? ज्यादा magnetic field lines कहाँ पे नजर आ रही है? Congested. Yes. Anyone? At which point in the bar?
Near the poles.
At the poles. Exactly. तो इसका मतलब ये है कि मैग्नेटिक फील्ड लाइंस आर क्वाइट डेंस एट द पोल्स. तो मैग्नेटिक स्ट्रेंथ भी सबसे ज्यादा उसके पोल्स पे होती है. मैग्नेटिक स्ट्रेंथ इज मैक्सिमम ओवर द पोल्स. हम ये लिख सकते हैं कि मैग्नेटिक स्ट्रेंथ इज maximum on the poles. Maximum on the poles. Maximum on the poles. Acha, why it is maximum on the poles? Because magnetic field lines are dense on the poles. अच्छा, अब इसका एक्सपेरिमेंट क्या हो सकता है? सपोज हमारे पास एक बार मैग्नेट है. This is the bar magnet. And you sprinkle and you shower so many iron nails on it. आपने बहुत सारी छोटी छोटी आयरन नेल्स इस पे ड्रॉप की. किसी बार मैग्नेट पे you are dropping so many iron nails. So what is going to happen? Most of the iron nails will be attracted at the poles. Most of the iron nails will be attracted at the poles, and very few iron nails will be attracted in the middle of the iron bar magnet. So this shows that magnetic strength is maximum on the poles. When you shower so many small iron nails over the bar magnet, most of the iron nails will be attracted on the poles. This shows that every bar magnet has maximum strength at its poles. Maximum strength होगी इसकी poles के ऊपर. अच्छा, इसके अलावा आपको क्या पता होना चाहिए मैग्नेटिक फील्ड्स में? देखिए बेटा, अगर हमारे पास एक पोल है और ये नॉर्थ पोल है और यहाँ पे हमारे पास साउथ पोल है, तो डेफिनेटली ये दोनों एक दूसरे को अट्रैक्ट करेंगे. तो इनकी मैग्नेटिक फील्ड लाइंस ओवरलैप्ड हो जाएंगी इस तरह से. just like electrical charges. If you have a north pole and this is the south pole, so they are going to attract each other. So their magnetic field lines will be like overlapping like this, because like poles attract. Acha, if you shift the location of the poles, like you place the south here and you place the north here, the magnetic field lines will also overlap, but their direction will change. So you have to remember, this is the property, this is a fact. The magnetic field lines always point from north to the south. Now, if you point to unlike poles, so like poles like this, आपने north and north अगर साथ place कर दिए, तो magnetic field lines are not going to join. Magnetic field lines are not going to join, and this is basically a sign of repulsion. जैसे ही आपके magnetic field lines join नहीं हो रही, देखें कट हो रही है अपने अपने पार्ट पे, so this is a sign of repulsion. और यहाँ से इस तरह से चली जाएगी ये वाली, और ये आउटवर्ड हो जाएगी like this. And if you place south south, means a south pole is facing another south pole. So what is the magnetic field pattern? It will be same, but the magnetic field lines will point inwards like this. Magnetic field lines will be pointing inwards towards the south like this. और ये outer वाली जो lines है वो इस तरह से point करेंगी. So like poles के लिए magnetic field lines overlap because they unlike poles के लिए हम ये कह सकते हैं कि unlike poles attract each other. Attract each other, so their combined magnetic field lines overlap. So their combined magnetic field lines overlap. Field lines overlap or join each other. मतलब join हो जाती है इसमें magnetic field lines. But for like poles, they repel. So magnetic field lines do not join or overlap. So magnetic field lines do not join or overlap. / overlap. देखिए बेटा, इसमें अगर कोई प्रॉब्लम मैग्नेटिक फील्ड के अंदर, तो मैग्नेटिक फील्ड असल में एक it's just a region in the surrounding of any bar magnet, in the surrounding of any magnet in which it can exert magnetic force of attraction or repulsion or any other